Hello everyone, my name is Pengzhi and I'm studying at the Beijing University of Technology. I'm glad to have the opportunity to introduce this research work. The title of my paper is Recognition and Diagnosis of Computed Tomography Image Using Reconstructive Techniques. Next, I will introduce it from the following four parts. The number one, research background. The number two, research objective. Number three, research methods and results analysis. Number four, research conclusions. The background. Colorectal cancers are developed from colorectal polyps. The early detection and removal of colorectal polyps may significantly reduce the incident rate of colorectal cancer. Colorectal polyps are characterized by small space. After some research work, we have four ideas as shown in the following picture. Number one, is the original image feature a good classification feature? Number two, is there a relationship between image information entropy and recognition results? Number three, what image features are important for recognition results? Number four, can we use important classification features to generate new comprehensive image? Therefore, we set two research objectives and then carry out experiments. Number one, we need to explore new features that can improve the effect of classification. It's necessary to improve the accuracy of automatic classification. Number two, we want to find out the influence of image entropy of classification results. The research method. We propose a diagnosis and classification method of colonography CT image based on deep learning and multi-space recognition. As shown in the picture, we extract the gradient features and RBP and local binary pattern features from original images. The A is a gradient image, the B is RBP image, the C is original image. We used the methods of multi-space image recognition image reconstruction to generate new RGB images. In other words, the new image is the image containing three channels composed of gradient features, grid features, and RGB space. So we performed various combinations of three features to obtain six sets of images. As shown in the picture, there are six groups of reconstruct images used in the experiment. A, B, C, D, E, F. We used the six groups of datasets to train and verify the classification results of improved ResNet 13.4net. We removed the average pooling layer and a few connection layer of the original ResNet 34 model, and then we add the ReLU 1 layer, convolution 1 layer, ReLU 2 layer, convolution 2 layer, average pooling layer, and a few connection layer in turn. 6 groups of comparative datasets were classified on the improved model. The results analysis. Number 1, by observing the value of group A and group B, it can be known that the indicators of the group B and the group B are higher than group A, such as ACC. Number 2, the indicators of the group F and group B are almost the same, and some indicators are even higher than group B, such as F1. As can be seen from Table 2, the image information entropy of group B and group F is very close and smaller than group A. Number 2, as shown in the Table 3, the p-value of group 1 is less than 0.05, which indicates that there are obvious difference between the two groups of data under the condition of large sample. As shown in the picture, the images with smaller information entropy will get better classification results. Besides, we can also see that the F1 with F1 with the gradient feature image is very high. We found that the ACs of group B and group F was higher than that of group A, and this upward trend is obvious. Research conclusions. Number 1, by comparing the results of the experiment, we found that the method of multi-feature fusion is effective. Number 2, the gradient features play an important role. A new RGB image containing 2 channel gradients and 1 channel RBP is very effective for classification. Number 3, we found that the information entropy and the classification effect show opposite traits of change. Number 4, the original feature of CT image is not ideal classification feature. Thank you for listening. If you have any question, please contact me by email. Thank you.